One of the important things that you'll need to grasp in terms of security from a Cisco router and switch standpoint is being able to deal with access lists. Now, the word access list actually can apply to a wide variety of different constructs on routers and switches, so we want to unpack and peel back the layers a little bit and get more specific on what that means. First, let's just cover some basics in terms of Cisco access lists. One of the first things to understand is that Cisco access lists were introduced to their routing devices almost as far back as you can go, for instance, version 10.0 of iOS. Now, since that time, the types of access lists have multiplied and require some differentiation. Now, pictured here is the basic layout of a Cisco routed and switched network so that we can show the basic types and then the basic application of access lists. Now first, understand that routers have very straightforward interfaces such as LAN, WAN, loopback, and such. And generally speaking, you'll deal with interfaces and sub-interfaces with respect to access lists on routers. Now switches are more complicated because they have different ports that you need to consider as well as just interfaces. On a typical layer 3 switch, you're going to deal with additional types of interfaces and ports such as trunk ports, which by the way you can also do with routers, layer 3 ports, ether channel ports, and then access ports. Another thing that you actually see pictured on the switch is an SVI or switched virtual interface. These are VLAN based interfaces that exist at layer 3 on a switch. Now, one of the types of access lists are called router access lists. Sometimes they're called RACLs, R-A-C-Ls, on switches, and on routers they're just simply called ACLs or ACLs. And they can be applied to any of the interfaces on routers and SVI ports on layer 3 switches. Now, ACLs may be applied on switches in interfaces in, for instance, layer 3 or routed mode, switched virtual interfaces, layer 3 interfaces, and so forth. But just kind of gives you an idea of where router ACLs fit into these environments. Port ACLs are exclusive to switches. You will not find port ACLs on routers, and they can be applied to the physical ports of the switch. The supported port ACL types are standard, extended, there's also MAC, and there are some other things that you can do with port-based ACLs. But understand that they're limited to inbound traffic and they are applied to physical interfaces only. There's some more nuances to that, but that basically gives you an idea of how port ACLs fit into the larger equation. Then you have MAC address lists. Remember, MAC addresses are the layer 2 hardware-based addresses that exist on switched LANs. They can be used on both routers and switches, and they can be used for filtering for 48-bit MAC addresses, but the syntax between routers and switches when it comes to MAC address lists are actually very different, so keep that in mind. Now, have you ever wanted to filter between devices on a VLAN without having to apply multiple access lists across various interfaces and various devices? This is really what VLAN access lists do. VLAN access lists actually filter within a VLAN on a switch. So you don't have to do port-based ACLs, for example, all the way across the switch where it's pointing to trunks and access ports and such. You can actually just do VLAN access lists where it filters all traffic going between different ports on the actual VLAN. Now finally, understand that this particular discussion of access lists is not exhaustive. There are other types of access lists that are now obsolete and probably going to be outside of any normal practice that you're going to run into. You may come into some legacy environments, but generally you're not going to see these types of access lists that were pictured here. IPX or Novell access lists, AppleTalk access lists, protocol type code access lists. They certainly are still valid, but you may not deal with them on a regular basis. MPLS access lists, if you're working in a service provider environment, you might, and then DECnet access lists. The IPX, AppleTalk, and DECnet you'll very likely never see. Now, just as there are various types of access lists, there are also many uses for access lists. You can actually do packet filtering, where you can actually apply it to a physical interface, for instance, on a router, and filter traffic at the layer 3 or even layer 4 level. You can also use them to limit virtual terminal access, your VTY lines on the router. You can apply them for route filtering, distribute lists in routing protocols. You can perform policy-based routing, understanding what you're trying to match. And also, both network address translation and VPN actually use access lists to be able to identify traffic. So, various uses of access lists. The next principle we want to cover in this lesson is the principle of wildcard masks. Now, one of the more challenging things to get used to regarding access lists are the concept of wildcard masks, because the format is the mathematical inverse of subnet masks. Here you actually see an IP version 4 address and a wildcard mask, just as you would see in an access list. Because it seems so opposite, you may wonder if there's a way to easily calculate these, and the answer is yes, in fact there is. Now, to illustrate how to convert between standard subnet masks and wildcard masks, let's actually start at the beginning. First, here we have an IP version 4 address. In this case, it's 172.31.12.0. Next, we add the subnet mask. In this case, we'll just use a simple /24, which is the mask 255.255.255.0. Don't worry about any of the class lists or any other aspects of that. Let's just look at this for what it is. In access list formatting, the subnet or prefix remains in the same format that you would use with relation to other aspects in routing. So mathematically, you can just carry the value down. It stays the same as 172.31.12.0. Next, add an all ones mask 255.255.255.255 to the equation for the subnet mask. Next, subtract the all ones from the subnet mask, and you're going to get negative numbers. Just disregard them. All you're looking for is just the digits themselves. When you do that, you will end up with the exact inverse of the original mask, which is what you will be able to use with access list configurations. Now, this is a critical point to remember. This only applies to iOS devices, namely routers and switches. When you actually get into the Cisco Adaptive Security Appliance, the ASA 5500 series, you will not have any use for wildcard masks. Instead, you're just going to use the standard subnet mask. So please remember that. It's a critical point. Now that we've covered wildcard masks and just some of the types of access lists and so forth, now we want to actually drill down into access list mechanics, how they operate, how they work. Now, access lists perform a logic function that decides if the criteria specified either matches the expression or not. It's similar to a decision point in a flowchart. Now, if you've done any programming at all, the same principle applies to things such as if-then statements. The if portion of the operation determines whether or not there is a match. Think of it as a 1 for a yes in binary or a 0 for a no. Now, this applies the ability to apply test criteria to packets, and that's what makes ACL so powerful in networking. Now, understand that essentially they're decision filters, and as such, you have 3 keywords. Remark is one of them, but remark just allows you to be able to put some sort of a comment in. But essentially, there are only 2 keywords you need to be familiar with. These appear in each ACL entry. An ACL stands for Access Control List, and in some cases, for instance, if you're doing a named list, you can actually have multiple entries, and then you have something called an ACE, which is an Access Control Entry, which is one line in an access list. So ACL, Access Control List, is the entire access list, and ACE, or Access Control Entry, is one line in the access list. So following the match or no match logic test, the programming of the access list applies one of these 2 actions that you need to know and understand. The first action, and it's a keyword in access list statements, is the word permit. And permit basically means if the match criteria is true, then let the packet pass. Now, in some access list applications, for instance in routing and others, it may just simply be a test of whether or not the test itself matches. Generally, when you apply an access list to an interface as a packet filter, when you have permit, it means to let the packet pass or allow the data through. The next keyword is deny, and it probably goes without saying that deny is the opposite of permit. It means to drop the packet, to filter it, to discard it. And again, the actual effect may be a little different in terms of route matching and stuff like that in routing protocols, but for packet filters, which is really what we're talking about, it just simply means drop the packet. Now, a couple of other just general points to understand and consider when dealing with access lists is that access lists use a top-down processing model. This basically, just in plain speech, means the first statement in the access list is evaluated. First, does it match? Is it going to permit or deny? And if there's no match is actually when it moves on. If there's a match, all processing immediately stops. For instance, if you have 15 lines in an access list and the first one is matched with a permit deny statement, it immediately stops processing additional statements. Another important point to remember is that you need to place more specific entries before the more general entries. if you put more general entries first, there's not going to be any matching done on anything that follows that. So if you have, for instance, access list 1 deny 172.31.0.0 in the appropriate wildcard mask, and next you have permit host, and there's just a variety of ways to do this, it'll never actually get to that because the first one would be matched before anything would be matched in the more specific. So start with the specific, then go to the more general. Another thing to keep in mind is at the end of an access list, there's an implicit deny any, meaning if you don't do anything else, there's a deny any in the programming even though you don't see it. I think as best practice, you ought to go ahead and put that there, but that's a part of something that you need to keep in mind. So if you have a lot of permit statements and then you have deny any, which means anything that hasn't been matched in the access list, it may have a different effect than you intended. Now, there are a couple of keywords in access lists you need to understand and that automatically indicate the bits to use for comparison purposes. If you remember with default routes that 0.0.0.0 is the broadest possible representation of routes and is essentially what any means. Remember, the wildcard masks are an inverse value. So any will actually give you the wildcard mask of 255.255.255.255. It means match anything. The second keyword you need to keep in mind is the word host. This is the mathematical opposite. It means you are only specifying one set of bits and everything has to match. So it's only going to match one host. So the word any and the word host are important keywords you need to keep in mind. So I want to actually take a moment to sort of illustrate some of what we've talked about in terms of access lists up to this point. You can actually see that we're in our lab environment. We have one of our switches, 2900 series, and one of our routers, which is one of the newer 2800 series, to be able to sort of look at some of the differences in access lists. So let's start with the router. We were to do configure terminal. We start out with the word access list, question mark. Now we talked before that there are a number of obsolete access lists. For instance, here you've got your IPX access lists, which really have no real purpose in the networking that you're commonly going to be dealing with. But notice here you have standard access lists. We'll talk more about these later. Extended access lists. We talked about protocol type codes, notice here. MPLS and your MAC address lists. Now for instance, if we were to do access list, let's say 8. Remember we talked about our different types. We have permit, deny, and remark, which just as a comment, it doesn't really do anything. So if we were to do deny, notice our keywords that we talked about. We could just do 172.31.0.0, 0.0.0.255, and you can see that's one way to do an entry. There's also IP access list, standard, and we'll talk about standard and extended access lists later. We talked about access control list, which is what this is creating, and then access control entries, which is what we put here. Okay, so I do deny 172.31.0.0, and then our wildcard mask and so forth. So we'll just go ahead and delete that list because we really don't want to do anything with that yet. That kind of gives you an idea of on routers. Now on switches, and this is a layer 2 switch, so some of what we're going to have is going to be pretty limited. Notice you have your standard access list and extended access list, protocol type code, and so forth. The access lists are defined the same in many ways, but there's some substantial differences between what switches have as far as access lists, and layer 3 switches would have more, and what routers are going to have in terms of access lists. So just a little bit of a way of exploring kind of what's going on in the world of Cisco access lists. Now to wrap up our discussion on access lists, let's just go over some critically important terms that you need to know with relation to this introductory section on access lists. First, the term access list, which is a Cisco decision-making feature or structure allowing a device to match a given address and act as a packet filter on routing devices. We've talked about that at length. Permit, specifically with reference to access lists, is to allow the matched criteria to the interface or the process involved. To the interface of using it as a packet filter, to the process if it's routing or policy-based routing or something of that nature. Then there's deny, again, specifically with reference to access lists, to not allow or to block the match criteria to the interface or process involved. Then, of course, there's a wildcard mask. In access lists and routing protocols, the mathematical inverse of a standard network or subnet mask. Thank you for your kind attention, and we look forward to having more to say on access lists shortly.